Is this starting? Hey everyone, we're going to talk about rate of change today, and I am using different equipment. All my stuff's at school, so hopefully you can see all that. Okay, I know you're probably thinking we've done rate of change before. This is going to be no big deal, and it isn't. It's just one little step further that we're going to take a look at. This is from Springboard, and so what I want to point out is a lot of times Springboard, which I really like, we'll use a real life situation. And then even though we're in 14.1 now, when we get to 14.2, they're gonna reference it back, and 14.3, they're gonna reference it back. So I wanna make sure I don't just skip over it. Okay, so the situation is there's this lady who works in a store, like a dog store where I guess you sell dogs, or a kennel where she feeds dogs. She's feeding dogs. And here is the weight of the dog. She is looking at the tag or the label that's on the food, and she only sees this section. The other part's ripped, and so she can only read this part. Okay, so if she just looks at this information, she sees that if the dog weighs 3 pounds, it should get 3 ounces of food, 12 pounds, 12 ounces of food, 20 pounds, 20 ounces of food. All right, so just looking at that, we're gonna write an equation, and W is gonna be the weight. So that's kind of like our X, because the weight of the dog is going to determine how much food he gets. All right. So when you look here, you're going to say f of X, or instead of X, we're going to say f of W, because it said function notation. F of W equals W, because if W is 3, then he gets 3 ounces of food. Okay, don't worry about it, that it's pound to ounces. All right, so the lady then goes to feed all these dogs. And then she realizes that, some of the dogs are 150 pounds, and so does she have to give them 150 ounces, realizes that the rest of the label is totally different. And so now this is the real label. And so you can see here, this was a linear function, right? And then start looking at this. So this was the beginning, what we just talked about. And then all of a sudden, when the dog is 50 pounds, he gets only 35 ounces of food. And when the dog is 100 pounds, he gets 60 ounces of food. So you can see that this is a little bit different. And when it's greater than 100 pounds, now he gets 60 ounces of food plus 1 ounce for every 10 additional pounds. So we're going to start looking at this and writing out some equations. Okay, so we already did the equation for a small dog. And basically what's happening here is they're saying, well, if the dog is considered small, which is anything less than or 20 or less, if the dog is considered small, that they get one kind of food. Well, I say one kind of food, but I mean one kind of measurement. There's a linear equation for that. And if the dog is mid-sized, and that's between 20 and 60, then there's a different equation. And if the dog is larger than 100, that's a different equation. So basically we have one equation for small dogs, one equation for mid dogs, and one equation for large dogs. And we're going to go ahead and try to figure out what those equations are. Okay, so here's how I did this, because this is a little bit tricky. I know that I want the rate of change, right? And so we did that for this part down here. So we've already done with small dogs. So let's look at mid dogs. Well, the rate of change, so I'm just looking at this section here, okay? The rate of change for mid dogs is, I'm going to do the change in Y. So 35 minus 20, 15, divided by 30. Okay, I get a half. So my rate of change here is 0.5. But then I want to make sure it's consistent in this part too. 60 minus 35 divided by 50 is 0.5. Oh, good. So this right here, so it was like this part was one function, and now we have a different function here, and we figured out the rate of change. So I'm already thinking slope y equals mx plus b, slope intercept form. Y equals mx plus b. All right, and I know my slope. I know my slope is 0.5. And I have to figure out my b, which always gets me a little confusing. Well, what was the smallest this dog could be? What was like the starting point? It was a 20-pound dog. So I know I have to have 20 here. And I'm going to change this stuff in a minute. And I know a half is my slope. Well, what is going to be my x? I start thinking, well, okay, if the dog, just in my head, if the dog is 22 pounds, sorry, I should be looking over here. If the dog is 22 pounds, then it should get 21 ounces of food, right? So I'm going to have to take my x and subtract 20, all right? Because that's gonna just be 1. So let's see how this works. If I have 22 in here, because in my head, right, if the dog is 20 pounds and it gets 20 ounces of food and it goes up a half, every pound it goes up a half ounce, at 22, it should be getting 21. Okay, so I'm gonna just go ahead and distribute that, or yeah, I'm gonna say 1/2 x minus 10 plus 20, combine my like terms, y equals 1/2 x plus 10. So this is my equation. Now, if I put it in function notation, I would say f of w equals 1/2 w plus 10. And I could go ahead and figure it out. If I put 100 in here, 100, a half of 100 is 50, 50 plus 10 is 60. So it looks like I'm good to go. Okay, so this is the answer in function notation. All right, now let's look at a large size dog. So a large size dog, very similar. I'm going to start the same way. Y equals mx plus b. I can see that we're starting at 100 pounds, right? Sorry, we're starting at 60 ounces of food is what we're starting at. Okay, so then how much is it going up? Here it tells me for every 10 pounds the dog is, it's going up for 1 ounce. So my slope is going to be 1/10, and I'm trying to figure out what is going to go in here. Well, if the dog starts at 100 pounds, then I have to do x minus 100. Sorry, I'm running out of room. Okay, so let me write that out a little better. Y equals 1/10 x minus 100 plus 60. All right, so y equals 1/10 x minus 10 plus 60. Y equals 1/10 x plus 50. Okay, and I'm definitely going to double check this because I feel like we have a lot of fractions in here. That's a 50. I really need to write that better. Okay, so we know that if the dog is 110 pounds, right, it's going to be 61 ounces of food. So if I put 110 times 1/10 plus 50, I get 61. So I am in good shape, okay? All right. So see, it's kind of the same. We're just looking for the slope, what the y-intercept is, and the only thing that's different here is we're having to go back and subtract, because it's not a complete linear function. Okay, describe the rate of change and express the rate of change per pound. So this is a totally different situation. We're not talking about the dogs anymore. We're talking about grapes. Here are some prices of grapes, 0.5, not prices, sorry, amounts, weights of grapes, probably 1/2 pound, 1.5 pounds, 2 pounds. And let me put my decimal there because it looks like 20 pounds. And then this is the cost. And so let's see if this is a linear function. Well, I should have a consistent rate of change, right? So I'm going to subtract 480 minus 360 and divide it by, there's only 0.5 difference there. So this rate of change is 2.4. Let's hope I get the same thing up here. Yep, 2.4. Okay, so my rate of change is 2.4. So determine the rate of change. The rate of change is 2.4 dollars for every pound. All right, so for every pound, I'm having to, the price is going to increase $2.4. Okay, is this a linear function? Yes, it is, because the rate was constant. It was a constant rate of change. All right, I wrote just a few more of these problems here, so take a minute and copy them down. You can pause it, and I'm just gonna, these should be pretty easy because we've talked about many of these problems before. It says, Tom has read 40 pages of a book, so he's on page 40. He plans to read 12 pages every day. Write the function, okay? So we're gonna say f of x equals, Well, what's the y-intercept? 40. He's starting at 40. And then he's reading 12 pages a day. All right? That's kind of how these are. I had $2,000 in my bank account. After 5 months, I only had $1,020. Write the equation. All right? So f of x equals, what's my starting point? $2,000. Now the money's going down, right? I started with 2,000, I end up with 1,000 something. So let's find the rate of change. To do that, I can make like a little chart here. At 0 time, I was at 2,000, and at 5 months, I'm at 1,020. And now I can do my change in y over my change in x. Divided by 5. Whoop, sorry. Oh my goodness. So it's $196. And it's going down by $196 a month. Okay? All right. I'm planning to have a party. The location costs $500, and I have to pay $100 per guest. So my one-time fee is $500, and I'm paying $100 per guest. And I know sometimes this gets a little confusing, like, am I having to put negatives here? But because I'm paying everything out, so like that's how much my total bill is. And usually on a bill, even though my bank account's negative money, my bill, it looks like it's a positive number, okay? All right, so today what you are going to do is you are going to practice these problems on the next page and then submit your homework. All right, thanks.